Alright, so this is practice quiz number 5 for AP Calc AB, but this will also be used for BC2 because 60% of the BC exam is AB work. Here we have 22 minutes to complete 10 questions. We are not allowed to use a calculator, and I'll try to use all the time as I possibly can. Last time I did go into a bit of an issue of going a little bit overboard with my explanation, so here I'm just going to be as short as possible, and if we have time, then I'll explain my solutions in a little bit more depth. But we have 10 questions, 22 minutes, so let's get started right now. Um, I guess, yeah, 3, 2, 1, let's go. Wait, first question. Okay, I didn't read what the context of this was, so I don't really know what the questions are going to be. That is not necessary. Okay, so first question. 1. If f prime of x is uh, 2x minus 2x and f of e equal to e squared minus 2, then f of 1 is equal to what? Alright, I'm assuming this has to do with an integration problem. So you have two f of e and f of 1. So based on the first fundamental theorem of calculus, if we take the derivative from 1, sorry, the integral from 1 to e of f prime of x dx, right? That should be, what is it, f of x. The integral of f prime is f of x from 1 to e. So that would be f of e minus f of 1, right? So that means if you take the integral of 1 to e of f prime of x, which is 2x minus 2 over x dx, let's do that right here. That is equal to x squared. This is inverse power rule basically, and I know it's just 2 times 1 over x. The integral of 1 over x is natural log. So then now this is going to go from 1 to e. So here we plug in e into there, so we get e squared, what is it? And then minus 2 natural log of e, subtract by putting 1 into there, so it'd be 1 squared minus 2 natural log of 1. Natural log of 1 is 0, so all of this goes to 0. Um, Here, natural log of e is just 1, so what we're left with is e squared minus 2 minus 1. So that is e squared minus 3. And that is equal to f of e minus f of 1, right? And we've given that f of e, right? F of e is e squared minus 2, and we have minus f of 1 right here, is equal to e squared plus 3, right? So here the e squareds, they cancel each other out. And then if you add 2 to both sides, we get negative 1 is equal to negative f of 1, which means f of 1 is equal to 1. So that's A right there. Probably a bit slow one time, but okay, let's move a bit faster. 2, acceleration a of t is equal to 9 cosine 3t. Okay, okay, so this I can see this is reverse chain rule automatically, right? So we're trying to find position, which means we're going to find the integral. This is u substitution, but I already know just by just dealing with these for such a long time that this is going to be 3 out here, because when you take the derivative, you're going to multiply by 3. So when you're taking the integral, yeah, so when you're going to be multiplying by 3 when you do chain rule. So when you're doing the other way around, you have to divide by 3. So here we have 3 sine t, and then when you take the integral again, it's going to be negative cosine t. That's going to be the start, at least. So it's going to be A, B, or C. Okay, fun. That is not helpful at all. So we know um, when you take the integral, right, you're always going to have plus c, right? So this is basically the integral of a of d dt, right? So you're going to have these plus c right here. So here, they said v of 0 is 4. So if this was 0, v of 0, then you just plug in 3 sine 3 of 0. So this sine, that's just sine of 0 is 0. So then you just add on 4 to there, right? So now you have to take the integral of this, because position is the integral of velocity. So then now that would be a plus 4t, right? And then this is 0, x is 0, then of course you have to do plus c, right? So x of 0, that is negative cosine of 3 to the 0 plus 4 times 0 plus 2. And many people might make the common mistake thinking that cosine of 0 is 0, but it's not. It's 1. So here it's negative 1 plus 0 plus c, and they're given this as negative 1. So c is actually just going to be 0 right here. The answer is B. So there's no c, just that. All right, let's move on. 3. F of 2. Um, okay. Okay, I'm gonna come back to this. This is weird. Oh, slope fields. All right. Uh, dy over dx. Slope fields to the following equation. Okay, right off the bat, I see right at y equals 1, the slope is 0. So I'm assuming, and if you look at all the same rows, at every single y value, every single height, the slope is the same. So that means the slope is dependent on y and not on x. Because no matter what x value it is, it's only dependent on the y. So automatically A is gone and B is gone. So what we're left with is C and D. C, so now we put y is equal to 1, right? If you put 1 in here, right, dy dx, if y is equal to 1, that's the king. It's 1 minus 1 equals 0. Is the slope there 0? Yes. So it has to be C. If you do D, for example, right, then the slope is going to be our y value 1 plus 1 is 2. And over here, the slope is 0, not 2. So it can't be D. That means our final answer is C. All right, let's move on. Which of the following equations is a solution? Okay, whenever you have solutions like this, first of all, okay, y double prime plus y prime minus 2y is equal to 0. I don't like these at all. But okay, basically what you have to do is you got to try each answer choice. So here we says y is equal to natural log of. Okay, this is still going to take way too much time. I'm just going to move on. 6. The table. Okay. So in which of the following intervals must be there a number c such that g prime of c is equal to 4? So automatically they're using c, and they're using c as there's a very purposeful reason why they're using C. Because this is IROC, right? Instantaneous rate of change, right? But whenever they have C, that means they're probably going to use A and B. And what they're trying to use here is average rate of change. So they're just taking a slope between 2 points. And they're saying, okay, if you take the slope between 2 points, like let's say this slope right here, right? There's and if this is a function that's a continuous function, right? There's going to be some other point along that interval where you're going to have the same slope. That's what this instantaneous rate of change is right there. So now what we need to find is an average rate of change where from one point to another point, the slope is 4. Uh, so in that case, let's see. Okay, battery's running out. Let's hopefully it'll last. Um, So g prime of c is equal to 4. So now we're just trying to find 2 points where the slope is 4. That's right, we're trying to find the average rate of change. So from 10 to 12, right, from x is 10 to 12, we have g of x is 10 minus 6 over 10, 12 minus 10, right? So that's going to be 4 over 2. The slope is 2, so we can't guarantee that. Oh, if you want a name for this theorem, by the way, it's the mean value theorem. Let's see, from 12 to 4, right? So when you do g of 14 minus g of 12 over 14 minus 12, right? That is 8 minus 10 over 14 minus 12. That is a negative number right there, so it's definitely not 4. I don't want to do the calculations. All right, let's try 14 to 18, right? So you take the y, the change in the y, over the change in the x. So 18 minus 14. What is this? This is not, yeah, you have 4 minus 8 over 18 minus 4. Again, this is negative, so it can't be this. So what we're left with is d. Let's just check g of 20 minus g of 18 over 20 minus 18, right? G of 20 is 12 g of 18 is 4. And then, yeah, you have the bottom is 2. So then that's 8 over 2, which is 4. So that's the average rate of change. So that in that interval, there must be one place where the instantaneous rate of change, or the derivative, is also 4. All right. The table above gives us a value of continuous functions at selected values of h based on the information in the given table. Which of the following must be true? Uh, Continuous. Okay. H of x equals 2 equals exactly once. Uh, okay, for whenever you're seeing whenever something's true, you always have to find ways to break it. So here, you could pass 2 multiple times. I guess you can go up and down, up and down. Very terrible explanation, but you can go through multiple times because there's no restriction on the derivative or anything. So that's perfectly fine. H has a maximum of 3. Well, oh, x equals 3. I mean, it can go above 3, so you have 3 comma 8, right? And then you could go above it technically, and then you can go to 4, 10 comma 4, and then 12 comma 0, right? So you can go above that. So B can't be right. I think C seems pretty reasonable because it's a continuous function. So that means there's always going to be a left-hand side limit and a right-hand side limit. So I'm going to go with C. D, H prime of C is equal to -2 on the open interval. So this is mean value theorem. Let's see, this is G. So that we need to find the average rate of change from 10 to 12. So that is 0 minus 4, right? I'm just taking the y values of each of x values and I'm subtracting it by the x values. And that's -4 over 2, which is -2. And, oh, that is interesting. Um, I am still going to say C, though, because for mean value theorem to work, I think it also needs to be differentiable there as well. I think it's a very special case. I think D is a trap answer. But yeah, D is a trap answer. I think you can see it's definitely true because it's continuous. There's always going to be a left-hand side limit and a right-hand side limit that equals that same limit. So I think C is true. Um, okay. Oh, I'm like usually behind and then I get instantly ahead. That's crazy. All right. 8. F function f is continuous on the closed interval. Okay, so we have that information. F of -2 equals 7 and f of 1 is equal to -2. Of the following conditions, which could guarantee that there's a number c on the open interval where f prime of c is equal to -3. F prime of c is equal to -3. Oh yeah, so I think this is where we're talking about so what is this? 7. Okay, so let's just say okay, f of 1 minus f of -2. Here, I'm just gonna try something else. 1 minus -2. F of 1 is -2, and then yeah, f of -2 is 7. So yeah. Okay, so what they're trying to do, this is the average rate of change, right? This is taking one point and another point, and you're just finding the slope, right? And by this mean value theorem, whenever you have 2 points and you can take the slope between them, along that function, there's going to be a point in that interval, assuming that it's differentiable, that is going to have the exact same slope. So, but the condition for the mean value theorem is it has to be differentiable. So you just got to know those conditions, and if you know them, it'll be a lot easier and you could that's pretty much it. So that's how you solve that. You just need to know that mean value theorem, it operates on the fact that you need to know that it has to be differentiable, otherwise this theorem does not work. Uh, Hopefully this can last. Let's see. What is the value of B? Okay, I gotta zoom in. I keep like zooming out and then it's not that good. Okay, so 9. Limit as x approaches -infinity of oh, okay. So these are just understanding how limits work. These are not terribly difficult. Um, Plus 2x squared plus 1. Okay, so equals -10. So honestly, yeah, so you just look at the biggest power right here, the dominating term. Because these, as they go to infinity, these will be so much larger than all these minuscule terms. As you approach infinity, these will be absolutely nothing. It's the highest power terms that dominate. Just think about it in that way, right? So then now it's just, you think of it 5x b of x, right? X equals negative infinity equals negative 10. Um, So what we need is as x approaches infinity, this is going to become a really large negative infinity. It's also going to become a very large negative infinity. Um, but I mean, it's in the same thing. So like honestly, you can just cross this out, right? X cubed is on the top. So you have 5 over b is equal to negative 10. And then if you do the math, right? Uh, just what do you divide by? B is equal to a negative half right there. So that is b right there. Um, Yeah, I don't think so. That's terribly difficult. Just understand that dominating terms win. Oh, that is weird. Okay. Um. Okay, Verge. Nice name. Dy dx equal to x. Okay, we're seeing if they're doing it right. Initial condition. Uh, in which of the following steps? Okay. Yeah, she separated the variables incorrectly. That's right. But I don't think so. You can say um yeah, this is a function. This is a separate function. You need to do u substitution there. You can't just say because like say if you take the derivative of this back again, right? You get one over so say the derivative, right? Because integrals are the inverse of derivatives, so we can check our work by taking the derivative, right? We get 1 over this, but then we would have to multiply by the derivative of this inside, right? And this, it gets pretty nasty here. It's not necessarily this. So this, this person forgot to do use. All right, am I still here? Okay, I'm still here. Um, okay, I think I'm frozen. My computer's frozen, but uh, yeah, I can refresh. Okay, I'm still timed in here. All right. Uh, I'm just going to, okay, but the incorrect step is in uh, B. Yeah, because of U sub, she forgot to do U sub there. All right, let's go back to 3 and 5. I think I can still move this. My thing is frozen, but it's all right. Um, what is it? I'm just gonna do, okay, if y is equal to natural log of 2x. Yeah, I don't think so. That would work. Okay, so I don't think so that'll work. So I'm just gonna go with y sine, right? And then you just find each one. So y is 2 cosine 2x. Then y double prime is -4 sine 2x. So it's -4 sine 2x plus 2 cosine 2x. Yeah, okay, because the thing is you have sine and cosine, they'll interlap with each other, so you can't necessarily add them and accept it 0. So I think the only answer should be D. Yeah, so I'm just going to go D. I'm running out of time, so um, D would work there. Let's go on to um, 3. Okay, semicircle. So I'm going to assume, I'm just going to take the derivative of the 3. I'm just going to take -1 to 2 of f of prime. And because of first fundamental theorem, that's going to be f of 2 minus f of -1. So that's just going to be 3 times 3. So this is triangle, right? So it's half times from -1 to 2, that's 3. Height is also 3. So that's going to be 9 halves. And that's equal to f of 2 minus f of -1. So 9 halves equals f of 2 minus f of -1. F of -1 was -3.5. So that's f of 2 plus 3.5. So that's also 7 halves. So then f of 2 is equal to 9 halves minus 7 halves. So that's equal to 1. So I'm assuming that is C. Right there. Awesome. Let me see if I can explain that other one that I did super quickly. What was that? 5? Okay, so here, well, the issue is if we do natural log. So the thing is when we add all these together, it should be 0, right? When you take the derivative of sine and cosine, like you take the first derivative, second derivative, you're gonna have alternating or like overlapping sine and cosine, and you can't add sine and cosine together and expect it to be 0. So B and C are gone. And then when you take the derivative of natural log, you're gonna get like 1 over x or like 1 over x squared, and those will not be like terms in natural log. So A will be gone as well. But E is special, right? Because when you take e to the 2x, e to the negative 2x, so y is that, then y prime is um, -2e to negative 2x. Y double prime is 4, right? You still have that like term,